when to use Z-test. We are going to study 4 types of test in Z-test. Test of significance of single mean. And number 2 is the test of significance of difference between two means. Both of these tests are actually common in Z-test as well as T-test. Now, as a student, we have to face a problem that when to use Z-test and when to use T-test. Let us clear some doubts or some theoretical points. According to the senior statisticians and authors of the books, there are 2 approaches for using Z-test and T-test in case of these 2 tests. I prefer to tell one of the scenario as Indian author's approach. Indian author's approach and others' approach. Now, what is the difference between these 2 approaches? The main difference is that Indian approach, or rather the approach taken by the Indian authors, is to give emphasis on sample size. If sample size is greater than or equal to 30, that is called large sample, and we should use that test. That means if sample size is less than or equal to 29, that is called small sample, and we have to use T-test. On the other hand, the other approach says population standard deviation, or say population variance. They give importance to the fact that population standard deviation is known or not. That means the standard deviation of the population from which the sample or samples have been drawn is known or not. That is the important thing. According to that approach, the first thing is, if population standard deviation is known, we should use Z-test in both of these circumstances. And if population standard deviation is not known, then we have to use T-test. Now, for us, what we have to do or what we should do. Being students of GTU, Gujarat Technological University, we require to study this chapter, testing of hypothesis, Z-test, T-test as well as chi-square test, from Indian reference book, and that reference book follows this approach. The authors of that reference book follow this approach, sample size approach. If sample size is 30 or more, treat it as large sample, and for any large sample, any parametric test is to be performed as Z-test only. Now, actually, we cannot say arrive at any conclusion on the basis of these 2. We just have to follow our seniors. But which approach is better? I personally believe this approach is better, because to know the standard deviation of population is not actually possible. That's why there is concept of sampling. And that's why on the basis of the sample study, whether to draw same conclusion about the population or not, for that purpose we are using actually test of hypothesis. Then how can we believe that population standard deviation is known, or whatever statistics are available as population standard deviation or population variance? How can we rely upon them? Because when the study of population is not possible, we have to study the sample and draw conclusion about the population, that we know. That's why there is something like sampling theory. Then how can we believe in the population standard deviation or population variance which is known or available in various statistical data? Ultimately, if the history of the available population standard deviation or variance is actually say studied, it might be a point estimation of the population standard deviation on the basis of any sample which was drawn in past by any statistician or any analyst, and then according to test of hypothesis it was accepted as the population standard deviation or population variance, and today we are actually considering that population standard deviation is available or variance is available and so on. So my personal view is that sample size approach is better than the population standard deviation available or not that approach. And we require to study the topic from Indian book. That book follows the sample size approach. So we are going to use the sample size approach for particularly these two tests. This confusion is for these two tests only. There is no confusion of sample size or population standard deviation in case of any other test. So let me be clear. We will give importance to sample size in the problem. If it is the problem with sample size of 30 or more, in case of single or two means, we are going to use z-test. In case of these two similar scenarios, if the sample size is below 30, then we are going to use t-test. Is it clear? Okay. Now, under the title Z-test, we are going to study 4 different types of tests. These two are the first. So, first we are going to study only Z-test, and we are going to use the Z-test for 4 types of different tests. First is, as we stated here, test of significance of single mean. Then second will be test of significance of difference between two means. The third will be test of significance of single proportion, and the fourth will be test of significance of difference between two proportions. Is it okay? Okay. Now the first. Let us take the first case and check the steps or understand the steps. The case is a random sample of 400 flower tins has average length of 10 centimeters. Can this be regarded a sample from a large population with mean of 10.2 centimeters and standard deviation of 2.25 centimeters? Let us check the question again and make or prepare a list of the statistics available. The first part is a random sample of 400 flowers. What is this 400? Yes, it is sample size. So we have to use sign small n. Has the random sample of 400 flower tins has average length of 10 centimeters. That means this is the average length according to the sample. So we should use the sign x bar or bar x. That is the sign of sample mean. That we know. Can this be regarded a sample from large population with mean 10.2? This is the mean of the population. We are going to use the sign mu for population mean. And standard deviation of 2.25. Mind well, this is standard deviation of population itself. See, this is the sum, or this is a case where any of the two approaches can be used. If we use the approach of sample size is 400, that is 30 or more, that means we have to use Z-test. Not only that, This is population standard deviation. So according to the other approach, population standard deviation is known. We have to use z-test. That can be called ideal case of z-test. There can be no confusion for the students whether to use z-test or t-test. And mind well, in case of the standard deviation or other approach, if sample size is greater than 100, practically we have to use z-test. Because in the tables available from the reference books for critical value of t statistic, the degrees of freedom up to 100 is specifically there. In case of degrees of freedom greater than 100, we have to take infinite degrees of freedom. That means we have to use the critical value of z-test. So according to that point too, we cannot use t-test. Even if the standard deviation is not population standard deviation, say if this is the sample standard deviation, then also we have to use z-test. Because the sample size is greater than 100, or say the degrees of freedom n-1 in case of t-test is also greater than 100, that means it is case of infinite degrees of freedom. That means this is pure case of z-test. So confusion should not be there. Okay? Now, which formula? First of all, just try to visualize the formula in which all these are the ingredients. There are two same type of formula. One is z, x bar minus mu, or sample mean minus population mean, divided by standard deviation upon under root n. The similar formula is there in case of t-test. X bar minus mu upon standard deviation. What is the difference between these two? If we use small sigma, it is known as population standard deviation. If we use s, it is known as sample standard deviation. Yes, again, some of our senior statisticians or author differ in this sign. Some says we should take n-1, some says we should take n here. In case of t-test, there is small confusion, matter of confusion in case of t-test. In some of the reference books, there is n-1. In other some reference books, there is n. See, actually both the formulas are same. So, the matter is of selection of critical value only. Yes? Okay. In this case, we have to use, or rather we ought to use z-test. First of all, the first step is to decide null hypothesis. Mostly either null hypothesis or alternative hypothesis. Pardon, I should use the words. The wordings of the null hypothesis or alternative hypothesis are mostly available directly from the question. See the last sentence of the question. Can this be regarded a sample from large population with mean 10.2 centimeters and standard deviation 2.25? That means on the basis of this data, can we conclude that this particular sample has been drawn from the population with these two parameters? See, we can write the hypothesis on the basis of these words. The sample can be judged from the population with mean 10.2. That means we are accepting that the population from which this sample has been drawn has mean of 10.2. The sign is HO, mu equals to 10.2. Now alternative hypothesis. Alternative hypothesis is actually the counter argument against the null hypothesis. We are actually using the word the sample can be judged from the population with mean 10.2, or we can use simple words. The population mean is 10.2. That means the population mean for the population from which the sample has been drawn is 10.2. What is our counter argument? First of all, check the question. Is there any term which indicates direction of the alternative hypothesis? Are we going to prove that the population, if the population mean is not 10.2, then can we conclude that the population mean is less than 10.2 or population mean is greater than 10.2? Is there any such directional term in the question? No. Then just counter argument is the sample cannot be judged from the population which mean 10.2 or the population mean is not 10.2. And when we use the term is not, that means both the sides are open. The population mean can be less than 10.2, the population mean can be greater than 10.2. That means this is the case of two-tailed tests. If the case or particular problem is the case of one-tailed test, we can expect the directional term directly from the question. Is more than, is less than, has increased, has decreased, is more effective, is not effective, or any other, is taller than, is not taller than, smaller than. These are actually some directional or indicative terms, which shows that you have to take alternative hypothesis for one-tailed test. But there is no any specific directional term in the question. That means this is open case. If we are going to, or if we have to reject the null hypothesis that population mean is 10.2, then both the sides are open. If the population mean is not 10.2, that means population mean can be less than 10.2 or it can be greater than 10.2. That means alternative hypothesis the sample cannot be just denied, judged from the population with mean 10.2. That means population mean is not 10.2. This is case of two-tailed test. Is it now clear what is one-tailed test, what is two-tailed test? Okay. Now mind well, if the case is of two-tailed test, be alert at the time of selection of the critical value. But before critical value, we require the level of significance. Normally in our reference books, the level of significance is not given with each and every question. So in that case, we teachers prefer to take level of significance of 5%. So we are going to take level of significance of 5% in this case too. And in any other such type of case, without information of level of significance, you can take level of significance of 5%. So the next is level of significance 5%. What is level of significance? Let us take it briefly. Level of significance means probability of occurrence of type 1 error. Now the question is, what is type 1 error? Type 1 error is the if or even if the null hypothesis is true and we reject it, that is an error and that is known as type 1 error. So for the term level of significance, we can use another words, the probability of occurring type 1 error, or we can use the words the probability of rejecting a true or correct null hypothesis is 5%. So level of significance is the probability of rejecting a true hypothesis. Yes? The sign is alpha. 5% means 5 by 100. That means alpha is 0.05. The probability of occurring type 1 error is 0.05. Now this is two-tailed test. So before selecting the critical value from the table, we have to divide the alpha by 2. Alpha by 2 equals to 0.025. In case of Z test, the degrees of freedom is taken to be infinite. So we need not write the degrees of freedom. Now critical value of Z. It is open and shut case, 5% level of significance and two-tailed. You can check the table, the value is 1.906. Sorry, 960, not 906. 1.960. If the case Z test, two-tailed and 5% level of significance, the critical value is 1.96. The last row of table of T values. The last row, infinite degrees of freedom. Degrees of freedom infinite and column of alpha 0.025, not 0.05. Is it clear? Okay. Now formula, rather test statistic, or say we are going to find the calculated value of Z. Formula is x bar minus mu upon population standard deviation root n. Substitution 10 minus 10.2 upon 2.25 divided by under root 400. So minus 0.2 upon 2.25 divided by 20. Minus 0.2 into 20, you can write in that way too. It is minus 4 upon 2.25. So ultimately the Z value is negative. What is it? 4 divided by 2.25?
1.777.
Yes, 1 point recurring 7, so we can say that it is 778. It is negative, but we are going to use the sign of modulus. 1.778. Just to make the comparison of critical value and calculated value, we are using sign of modulus. Now how to arrive at any conclusion? First of all, for that purpose we have to compare the calculated value and critical value of Z. Z calculated, say it is 1.778. Z critical, it is 1.960. So we can say that the calculated value of Z is less than the critical value. Clear? If the calculated value of test statistic is less than the critical value, then we can conclude that null hypothesis cannot be rejected. So null hypothesis is not rejected in this case. Is not rejected. Let us first write conclusion and then we will go for further discussion. So conclusion is now mu is 10. This is say mean. Now what do we mean by two-tailed? 0.05, 0.025 and 0.025 area. If the mean comes within this range, the null hypothesis will not be rejected. In other words, the test statistic will not be greater than the critical value when the sample means come within this range. But if the mean is less than this value of mean, then the hypothesis will be rejected. This area of 0.025 is known as rejection region on the left hand side. Similarly, this area of 0.025 is known as rejection region on the right hand side. That means if the mean value is greater than mean value here, again the hypothesis will be rejected. But this is the area known as non-rejection region. If the mean value falls in this region, the hypothesis will not be rejected. Whatever mean value comes in these 2 points. So this is also known as critical value. See here Z is minus 1.96 and here the Z is positive 1.96. So say, just for example, say Z is minus 2.1. Where will be the Z? In this region, anywhere in this region. That means it falls in the rejection region on the left hand side. Suppose Z is positive 2.1. It will be there in this area, somewhere in this area. That means again it falls in the rejection region. So sign is not important. If the value is greater than 9.6 with or without negative sign, it falls in the rejection region. That's why I dare to use the sign of modulus. It makes the comparison for you people very easy. Otherwise you have to draw this diagram every time, you have to plot the values, you have to see whether the negative value falls in the rejection region, the positive value falls in the rejection region, and so on. It will consume more time of you people during the paper. It will actually create or increase some confusion among you. So I dare to use the sign of modulus. Many of the teachers are not using this technique. But I personally believe that simplification is necessary. That's why I am using the sign of modulus. Otherwise you have to use this technique every time. Number 2. One more thing. Many of our Indian books actually say ignoring this topic, that is known as p-value concept. Let us take this as a sum of normal distribution. We have already calculated z-score. Now in normal distribution, what do we do after calculation of z? We find the relevant area for this z value. That means area between z0 and z negative or positive 1.778 or so on. Is it? Just find the area for this value of z. What is it? It is for 1.78.
4616.
It is for 1.78, is it? Is 0.4616, is it? Okay. Now what is p-value? P-value means area of the relevant half of the normal curve, left hand side or right hand side, whatever the value of z is. It is 0.5, either it is left hand side or right hand side. So sign is again not important. It is 0.5 minus this area, 0.4616. The answer is known as p-value. What is p-value for this case? It is 0.0384. Okay. Now similar type of step is there. Compare p-value and your alpha or alpha by 2, whatever the case may be. Comparison of these two. Okay. P-value let us write alpha first. So the same sign will be there. Alpha by 2 and p-value. What is alpha by 2? For us it is 0.025. And what is p-value? It is 0.0384. Now we can compare these two. Alpha is less than p-value. If alpha is less than p-value, then the null hypothesis is not rejected. Instead of, or rather as a substitute of this part, we can also use this part. This is called critical value approach. This is called p-value approach. But to arrive at the p-value, first we have to calculate the critical value. It is the common. Up to this step, the calculations or rather the steps are common. But there are now two alternatives. After calculation of critical value, whether we are going to use the p-value approach, then we have to take all these steps. Find area, subtract it from 0.5, p-value, compare the alpha with p-value. If alpha is less than the p-value, the null hypothesis is not rejected. That means, on the other hand, if the alpha is greater than the p-value, the null hypothesis is rejected. And the same rather population mean is not, or is 10.2, whatever the case may be. So you can use the p-value approach too. Got it? To find the p-value, we have to find. That's why, as a teacher, I personally prefer the critical value approach if there is no specific question in the, rather specific expectation of the paper setter in the question. Directly comparison of calculated value and critical value. Yes, we can directly compare these two, we can directly arrive at the conclusion. That's why I personally prefer, or say bias about this technique. But this was the part of our study. How to calculate p-value, what is p-value. I tried to explain all these in brief. Got it?